Okay, I apologize for the multiple videos. I had some issues with my phone. So we're determining the standard form of hyperbola with vertices negative 4, 0, 8, 0, foci negative 8, 0, and 12, 0. Okay? So I gotta go out to 12. 1, 2, 12. So, the vertices are negative 4, 0. And 8, 0. Those are my vertices. Okay. So if those are my vertices, I know that my transverse axis is horizontal. I know that my transverse axis is horizontal if my vertices are such. Right. My vertices lie on a horizontal line, so hence my transverse axis goes from negative 4 to positive 8. So I know my form of the equation has to be x minus h squared over a squared minus y minus k squared over b squared equals 1. That's the equation for, a hyperbola when it's in, when the transverse axis is horizontal, okay? All right. Well, the next thing I know is that my foci were at negative 8, 0, and 12, 0. Foci right here, foci right here. Okay. Well, since the transverse axis goes from negative 4 to 8, all right? The center of this hyperbola would be in the middle, between the negative 4 to 8. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I count 6 units, 1, 2, 3, 4, 5, 6, that means my center better be right there at 2, 0. Okay? My center better be at 2, 0. Because the center will always lie at the midway point between the two vertices. The center will always lie at the midpoint between the two vertices. So my center is 2, 0. And really all I need to use this formula is I gotta know the center and I gotta know A and B. I've gotta know the center and I've gotta know A and B. So we already know the center, okay? So now we gotta figure out what A and B are. Well, again, I know that my vertices are 6 units away from the center. I just counted that. To go from the center to the vertex, I go 1, 2, 3, 4, 5, 6. So A better be 6. A is always the distance from the center of the hyperbola to either one of the vertices. A is always the distance between the center of the hyperbola and one of the vertices. All right. Well, the other thing I know is I know what C is, because I know where the foci are. The foci lie C units away from the center. The foci will always lie C units away from the center. So if I go from my center to a foci from 2 to 12, that means that C must be 10. If you go from 2 to 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, C must be 10. So now I know A and C, and I know that C squared is A squared plus B squared. Plug in what you know. C squared would be 100. A squared would be 36 plus B squared. Subtract 36 from both sides. Right? B squared would be 64, so B must be 8. So the B is 8. So now all I got to do is plug H, K, and B into that formula, and I'll have my equation. So x minus h squared would be x minus 2 squared over a squared. A is 6, so a squared is 36, minus y minus k squared. K is 0, so that's just y squared, over b squared, but b is 8, so that's 64. So there is the equation of my hyperbola, okay? There's the equation of my hyperbola. X minus 2 squared over 36 minus y squared over 64 equals 1. Okay? The last thing in this section that they talk about is eccentricity of a hyperbola. That's going to be something that's pretty easy. Okay? Eccentricity of a hyperbola. Eccentricity of a hyperbola. Okay? This is on page 933. Okay? Page 933. And it's still E and it's still C over 8. Okay? It's still E and it's still C over 8. So with that in mind, to calculate the eccentricity, all you gotta know is the value of C and the value of 8. Okay? All you gotta know is the value of C and the value of 8. So with that in mind, I'm just gonna leave example 6 to you because that's pretty easy. We know how to find C now, we know how to find 8 for a given hyperbola. So once you find C and A, plug them into that formula, and you can find the eccentricity. I think that's pretty straightforward. There is one more example, example 7, but again, I don't think it's too bad either. So this concludes 10.2.